Good morning, ladies and gentlemen, welcome back to another day of the video. Darren, how's it going today? Today it is a Wednesday morning. We don't have lectures today, hence why I'm still hanging out in my dressing gown. I should have got dressed, and because when you get dressed you start working earlier. Like it's 9 o'clock and I'm about to start programming, which is a bit slacky to be honest with you, but it's very important at least to try to stay in a routine even if you're out of that routine. Because the routine is often what makes you productive rather than other things. Rather than like you actively being productive, it's just that you have a routine that forces you to be productive. So anyway, got up this morning at normal time, just after 6, well, like 2 minutes past 6 o'clock. Had a shower, went in, and the reason I'm still in my, well not still, I've been a bit slower than normal is because I got Graham out this morning, and she was like running. I was trying to eat my cereal. She was like sat on my lap for a bit. I was eating my cereal, and I put her in my sleeve, and she sat in my sleeve for a bit. I was eating my cereal, and then she just started getting a bit hyper, and then I was unable to eat cereal and look after her at the same time, which was irritating. So I came in here, sorted out my daily vlog. Laura went to work. We both have like a sore throat, which I thought I did yesterday because I ate some potato too fast and burnt the back of my throat. But like I've just got like this lump in my throat. It's really horrible. So I'm fighting with that today. It means I'm going to have lots and lots of tea on tap. But today is a day of programming. We're going to be forging forward. I'm going to have my first fully implemented, very first fully implemented mutation running. And I'm going to run it against real code as well. I'm going to see what it can do. That's the plan, because yesterday, late at night, just after midnight, I managed to get it so that I can go through the entire project, any entire project, pull out all of the user created files, ignoring the unit test files, and ignoring files that I shouldn't be touching, like acceptance test files and shit like that. I can then feed that information to mutants. They've got to create what I'm calling over here a mutation. The mutation isn't changing the file, it's changing the contents of the file. The contents of the file will then be applied to said file at the end. Because I generate all possible, I have a function that goes generate mutations, then I've got a function that says apply mutations, and then it goes through and fires it off, because those two things need to be running in a relatively parallel fashion. Basically the mutation, the generation of the mutations is done from the source, or well, a copy of the source, and then which of the several threads I apply it to is decided at runtime when it's calculating. But yeah, otherwise I'm in my Jimmy Jams, and I'm nice and comfy. So let's get some work done. Let's put some glasses on. Let's get some work done. Well, we're running stuff at the moment. Stuff's changing here. Bam, there we go. There's a build. Running the tests. Swag. I don't know why I'm looking at it on the camera screen instead of the actual monitors. The tests have finished. We're in here. We're now trying to get at our mutations. So for each file, wait, hold on. These are relative file paths, aren't they? Probably gonna have to break out that loop. F5 in. Let's just try and pass this file. See what happens. We pass it. Goes through. Compilation result. Happy birthday. We generate all of this stuff. Okay. We are looking for some kind of addition that we can change. Throws an exception. Can't get one. Let's try. Oh no, it didn't go break. I mean continue on that. Don't I, not break. Take two, ladies and gentlemen. Like, the mutation is doing what it should be doing. What it's basically doing is it's looking for either plus, minus, divide, or multiply, and it's swapping it with another one of the same. And I'm running it now to see if it can actually pick stuff up if I feed it its entire project. I've got a breakpoint on the bit that actually calls stuff. So it's exciting. Oh, we are on the paths. So right. Wait, let's put breakpoint there so we can stop here in the future. Go. We are on. Okay, right. Pass it. Read the files. It's gone in again. Didn't find any, I guess, for that one. Okay, let's go. F5. We found one. Mother trucker. So Right, oh man, this is exciting as balls. So, what is our original file contents? Can I see that? Or have I just gone too far so I can't see it anymore? It's found this, throwing an argument exception here. It's manipulating the exception string. I don't think that'll build, but it's interesting nonetheless. We fucking did it, boys. While it is doing things that it might not necessarily be able to do, that is something that I basically can't stop. The amount of testing each one of these has is going to be really minimal as well. Ironically, the bit that is testing the tests is the bit that's most flawed, we'll say. Okay, so I've now got it so that I'm feeding out the right number of stuff and tests pass, so my build should work. There we go, we're away, running all the tests, hopefully none of these fail. Like this, I want to get an idea of just how massive this process is to take. I know of a lot of people who have done final year projects where they literally can't run it on their computer or something ridiculous like that. Because it'll just like drag their computer down to a halt. Because they say, I know someone who's doing like a multi-agent system where they have to simulate several drones all at once. That's going to be similar to this. Like, it's going to be a case of I have to run it for a couple of hours to see how it'll work. I'm trying to make it as fast as I possibly can do, but it's going to be telling, I think, to see exactly how well it goes. So I only have one mutant at the moment. That's something worth paying attention to. And we are able to generate, this is another thing as well, I'm catching exceptions to do that. Catching exceptions is usually quite slow, which is quite annoying. So I've generated a number of only 22 mutations. That's actually quite impressive. I'm quite impressed with that. Well, I'm not impressed, I mean like, there isn't, fed it my entire system. My system's quite big, but it's not huge compared, and it's generated 66 different mutations. All of those require a build. If it builds, a test run to figure out whether or not it passes each mutation. That's the scale that this program runs on. And bearing in mind the tests for this project take, what do they take? 6 seconds to run? 7 seconds to run. That's mental. That is, well, there, roughly 66 test runs. 66 times by 7 seconds. How long is that? But most of them will fail at build. But even so, that's madness. Oh my god, I'm so happy it works. It bloody works. I just need to make sure, I just need to change a couple of things there to... Oh man. Okay, so, what's the plan of attack now then? I have my mutations. I need to rejig this object a little bit, make it a little bit cleverer, and I need to improve the way that I'm building it. At the moment I'm literally just dumping the information in and just returning it out. What I want to do is like read that information a little bit more and find certain things. So this is so exciting. It's exciting, and it's like, oh my god, this is so cool. I kind of don't want to touch it because it's cool. I don't want to break it, and it's not like we've got a decent fair way to go. But the way it's been designed is, if you want to create new mutants, you essentially just have to write this method here and there. And you can just create one, create a new one, test them obviously, but you just spit them out and just add them into this collection, and then the program dynamically pulls out which ones it wants, it dynamically pulls out how to run them, and then it just goes, and then you've got the infrastructure. So essentially, as soon as the infrastructure's in, which is what I'm doing at the moment, it's literally just a case of just machine gunning out these mutations, and we're happy. Like, they're complicated as balls, man. I still don't possibly really understand them, but that's because I haven't created one from scratch yet. I'm using an example one that I found online. Well, I've edited it a little bit, changed the battery, but it isn't been completely created from scratch by me. So it's going to be a learning curve, getting used to Roslyn and stuff, but at the moment Roslyn is doing way better than a regular expression could. Problem is, I don't actually know how many mutations it should find. So it could be missing loads, and I'd probably never know, unless I embed them. But I guess that's what the tests are for me to embed them and see if I can pick them up. I think it'll only find, in fact, actually this is good. I think it will only find mutation, the first possible mutation in the file, not the last one. I think. I don't know. At the moment, to run on one thread, assuming it, like, very, very rough calculations, it's going to take about 8 minutes to run all those mutations. Assuming they all build and all the tests run, 8 minutes. And assuming that nothing else takes a really long time for some reason, or assuming things aren't quicker because builds fail or things like that. That's mad. Okay, but I think it's time to have a shower. Oh no, I've already had a shower. There's no need to have another shower. Get changed and come back in, probably with a cup of tea. I don't know, it's probably a bit too early for tea. But I do feel like I'm in my pyjamas too long now. I want to tackle this. Right, I just changed the project so that it will pull all files out of everywhere. So ignore that statement. It's pulling out all cases where I'm doing addition, subtraction, multiplication, division, and it's changing them all. And I have found how many is that? Sorry, 208 different mutations. In the core configuration helper, there's some in the mutant collection builder, there's some in the language controller builder. Holy shit! What is that? C# file helper. Christ! Should we recalculate then? Roughly, very, very roughly, how long are we expecting that to take? And it'll probably, like, this is an extremely, extremely rough estimate. 24 minutes. I guess I now understand how it's pulling out the stuff better. It was literally just finding the first and last in each file. I think it was then only taking one of the two based on... I don't even know what it was based on, to be honest with you. I don't really know why that code pulled out two and then only returned one. But now, pulls out one, pulls out all of them in the file and returns every single possible alternative in the file. So everyone you find... Holy shit, no it's not, it's 206 tribbled. Each one of those mutations is 3 different ones, because it's a plus and then they find a minus, divide and times. All 3 of them. So ignore that. Oh, Christ on a bike. So it'll take over an hour and a half to run. Are you shitting me? That's mental. The key important thing to remember is it isn't actually an hour and a half. It could take an hour and a half. In theory, if you ran it purely sequentially and you ran it, no, I just want juice. If you run it purely sequentially, no parallels, and every single build succeeds, so it runs all the tests. In the real world, what will happen is you'll run 10 of them at a time. Although the builds aren't parallel, the tests are. So you can run it as many different test solutions as you want. So up to however many threads you want to run it on. But the builds are sequential. This is what I mean about how this system, if it existed, is really expensive to run and do, which is why people don't do it, because it's such a strenuous task. My system's designed in a way where say the test running is going to be the hardest thing to do. I can pull out all 206 different, well, all 600 odd mutations. I can run them through a sequence of 10 build servers or 10 different build iterations on 10 different machines. That will speed up that process. I can then batch run all 600 across, if I wanted, 600 test runners, and then bang, happy birthday, get your results back. Like, it's built to be parallel, so it's like a services model where it doesn't care where the service is. As long as it can talk to it, it will do it. So I could put my test runners on a load balancer, and the load balancer will just go and just machine gun you around to each one that's running. I do think if I were to run this, it would be a cloud-based model. I mean, half of the idea was that you could take it to a company, they could put it on their own machines, their own build server, and run it as part of their deployment cycle, which you could. This is another thing to remember as well. Like, at the moment, it's pulling out all possible mutations. What it will do is it will pull out mutations, log which mutations it's done, and highlight them, and then it will retest the ones that failed every single time, and then it'll only test lines that have changed in the last previous run. So it's only doing so much because it's being bulk tested, essentially, at the beginning. I need a drink. I need to get back into doing work, man. They're just boggling at the idea of how long this motherfucker's going to run. Like, I have to run this as well. I have to do this run. When I have a suite of mutations, I'm going to have to run it on my computer. And it's probably going to involve Friday night starting it and then coming back on Monday and going, I wonder how it did. Okay, so you better hope that you haven't balked your results file or something silly like that. So, fun. So mutation generation is quicker now as well because I'm not doing it via catching exceptions. I've removed the thing that was causing the exceptions, so that's good. Right, okay, that less chin whack. Where's my fucking juice? Went to the loo on the way here and fucking left my juice in the living room. God damn. Keep finding a collection of bugs. There may not be, I'm just writing unit tests and I'm finding the bugs, which is why. There may not be 206. How many are there? We'll find out. 57 is much more realistic. Christ, if I did a bug, I'd accidentally left. I was only looking for positives, but I was only looking for and signs, but I was looping through 4 times. So I was basically quadrupling everything. So I guess 57... Well, 57 times by 4 is about 200 and... Well, it's 200 and something, but this will be picking up some things that are multiplications now. It was only looking for plus additions. It wasn't looking for anything else, but it was looping 4 times as if it was looking for something else. So, I now have... God damn it, this is why you write tests. I'm like, why is this failing? And I'm going through it with my test data, and I'm like, oh, so I believe now, how many times I have to do this, I don't know, but that is now 57 multiplied by roughly 7 seconds, divided by 60 is a much more conservative 6 minutes. Much more conservative. Oh no, did I times it by 3? Can't remember. Did I times it by 3? I didn't times it by 3, because each one of those is 3 mutations, so it's 20 minutes. That's much better than what I was quoting you a minute ago. I'm going to shut up talking to you and just try and make sure there's no bugs before I start going, holy shit, this is too many. But I'm really impressed with how much memory it uses. There really is not much memory involved. I'm very impressed with that. Done. So I now have a framework in which I can create mutants at will. An AP, basically a public interface that they all implement. As long as the interface does what it's supposed to do, add it to a list. The list was used to dynamically generate a collection of ones that we're going to run. It then goes through, produces all of the possible mutations that we're going to run in the test suite. Then we are going in now. Well, now I've got that all sorted, I need to now split those mutations across the different threads. That's where it starts getting a bit fun, because I've got to be a bit clever with my threading. Feed one mutation to one thread, another to the next. I think I'm going to have like them be available, basically. Next one to be available gets resubmitted again with another thing. I think that's the way I'm going to go with it. Yeah, that's my way. That's what I'm going to be doing, ladies and gentlemen. But first, it is time for lunch. So I'm going to make myself some sandwiches and watch a bit of TV or something. I don't know what I'm going to watch, actually. I have the bit of code that applies the mutation to the actual file. Dangerous. Now I'm going to start fucking around with files. And I'm going to start mutating the code that fucks around with files as well. But no, it's fine. All my tests happen purely in isolation. Although it is something to consider that I hadn't really considered. Is what if it's very easy for someone to use my program to do something pretty fucking malicious if I were to host my own service. But anyway, so I have that now. Shall we see how we do? how quickly it is. It's really, should be really bloody easy now to just go, right, call this, call that, done. First mutation went through and it failed. Oh yeah, ladies and gentlemen. I may need to pull this information out at some point, but for now, that's all I need. So, I'm listening to the radio that I missed out listening to this morning because I'm sad. That will then return out. We generate the results, go through this, process them, bang, out to this. This then returns the list out. We go to here. If the compilation was successful, then we stop. Right. So, I guess in the scenario where the compilation isn't successful, we need to undo the mutation. Do we need to undo the mutation, or can we just start again with the same thing? Because I overwrite it every time, I don't edit it. So if the build fails, we overwrite it with a new mutation. How about that? How about that, and we just continue to triple check until we have them? Oh, this is not tested, I'm literally just ambling through, having a look. Okay, ladies and gentlemen, we've done a little bit of rejigging. We are whacking that over there. So, we're now running it through, and we're stopping just before it gets scary on this screen here. But we are going to run it through and check for one that builds successfully. So that's what we're checking for now. We're starting the test run. Come on, 7 seconds, right, okay. So now, we step in to the, oh no, we're initializing our controllers. Alright, there we go. We go, why does that initialize it? I don't know. Anyway, we pull out one test solution. We're only using one test solution anyway, so there's a massive oversimplification. We apply it, we do a build fails, we go back around, we apply it, we do a build fails, with a different error message, I believe. No, because the, I'm changing a different file this time. Because I'm not looping through that file. Okay, right, cool, I'll adapt this. This is so fucking exciting, I swear to God. Right, okay, I'm literally buzzing here. So we start the program, we go like this. This is literally just the process of running it. I want to find one where the build works. Because it gets a little bit more finicky than this, because when I pull out well, I don't really care why the build didn't break. If the build broke, then I don't give a shit. Just kill the mutation stream. If the tests fail, I need to pull out which test fails. I don't currently think... Oh no, I do pull out that information. That's cool. Cool. First run works. We are now going through, and we're off. We're off, ladies and gentlemen. Building over and over and over again with loads of different mutants until we find one that builds. Bang! This is so fucking exciting. Right, okay, so the possible mutation that we've done is... Let's just pull this information to one side. So, see what I mean as well about... it won't necessarily be as slow as I'm telling you it will be. It's only really slow because that's when it goes through to the test runs. Test running is slow, building is fast. If a build fails, I don't really care. But if a test fails, then it... if it tests... Well, no, I do care if tests fail or whatever. But running the tests is more expensive than not... What? You know what I mean. Running the tests is far more expensive than doing builds. So it's a good job there's more builds than there are test running, that's what I'm trying to say. This is so cool because it's testing my... This is testing my testing. Okay, so here is the original on the left. Sorry, I was trying to remember. I have a thing where I'm pulling out a file and I'm editing the length of the thing. So it's picked out path.length -1 and it's turned it into path.length +1 on this side. And we're now going to test if any of my tests fail. Where is my command prompt? There it is. Oh, fuck's sake. It's because whenever I click on that it goes, oh, because this is in the way. Right, okay, there we go. So if I go F10, we run the tests. Come on, fail. Fail. Don't let the first working mutation break me. Hey, a test failed. That means I did a good job. It fucking works, ladies and gentlemen. I'm so fucking happy. Oh my god. Okay, I'm gonna do a full test run. A full... This'll pull out, I'm gonna stop it once it's finished all mutants. Okay, so I'm no longer checking what mutants it's doing. It's a black box. I'll stop it before it generates, and I'll stop it when it finishes. And we'll get a stop clock open, and we will time it. I won't let you sit here and watch me time it, because it might take a while. I don't think it'll take that long. Where's my timer? Oh, it's there. I remember where I put it. Right, we're just running the initial test runs now, and we are ready to rock. And now we lean back and we watch. Keep failing builds, because each test run takes 7 seconds. Clarify as well, this is running... Oh, there we go, test run. This is running purely in sequential. There is no parallelism there. Multiple tests failed. It's not very good, really. You should have several tests. Only a single couple of tests. How are we doing for memory? We're not exceeding memory, are we, massively? No? It's pretty fucking stable. That's what I like to see. So, yeah, it only takes 123 megabytes of RAM. Not bad. I don't think we've had one at the moment where the tests have successfully fully passed, which is good. But yeah. Oh, fucking hell, this is great. This is great. It works. It works, ladies and gentlemen. Well, maybe the test just passed there. Problem with this is I won't be able to see what the mutation was that made the tests successfully. Because I didn't do that. I'm basically doing a timed run. But this, remember, is... Oh god. Oh, this is so cool. Oh my god. Christ, ladies and gentlemen, that's skyrocketing a bit here. We had a lot there where it just failed a couple of times. Well, I guess, am I adding... Well, no. We're up to 300 megabytes of RAM. Okay, so I think we might have a memory leak in our build area. I might have to look if I need to dispose some shizzle whizzle. But Christ, that just went mental. There's definitely a lot of room to speed this up. So when it runs through and builds one, whether that build succeeds, it should be passed on to the test runner, which runs in a different thread to the main one. I've then got 10 of those threads that can go, and then it'll thingy. So I can, if I request 10 threads, I can get 10 different things running at the same time. So that's good. Yeah, so if I go through, build one, I call one, well, it's building sequential, that's the problem. I build a batch of 10, so let's say we've got 10 threads. Build a batch of 10, successful ones immediately get pushed onto the test runner. This is why I wanted to see this running before I started programming this, because it's going to take me some time. They immediately get pushed through to the test runner. The test runner then goes on and runs those tests. Those tests can all be run in parallel, so you can have 10 running all at the same time. They're obviously going to run a little bit slower. I don't actually know. We'll experiment. But yeah, so we'll run all the tests all at the same time. As soon as the test run stops, that thread then becomes available to rebuild, and then you continue on in like a chain like that. It's going to be a bit messy dealing with the threads like that. But at least it's not C. At least it's C#. And yeah, no, it'll be pretty easy. It's just, when I mean messy, it's going to be messy testing it. But really, do the tests care if you're running it in threads? No. So I'm really interested to see if any of these test results show me failing. It kind of whizzes past too quick for me to spot if I've missed anything. If this highlights an area to me that I haven't tested properly, then I've won. I basically can just get my fucking dissertation now. We do need to figure out this mess before I run this all weekend and trash my RAM. I mean, I've got 16 gig, so I'm happy for it to do an error on small test runs. But if I bulk test an entire suite of tests for a weekend, I'm sure I'll go over 16 gig. But yeah, I'm sure C# would then clean it for me, but you never know. So it took a while, but it found, I don't know if this is a good thing or a bad thing, 0 errors. My testing is better than the tool I created to test it so far, which is good. I stopped it on the last on a breakpoint at the end, and then like very quickly added this thing in here. Which let me do it. Obviously that's running in debug mode, but I don't think it'd be much faster. Like, the slowest things in the system aren't the system itself, it's jumping out to files and running these two processors that are off files. What I'm imagining is this beast on a RAM disk with a huge ass memory leak. No, it's not. But it works. It works. All I need to do is now do it properly. Do it again, but better. Holy mother. That is so cool. Laura just texted seeing if I could see the sunset. I kinda can't, but it looks great. And with that, ladies and gentlemen, we're off to bed. I've checked in all my code and stuff. It's now been pushed over to my laptop. The tests, I'm happy with the progress we've had today. Tomorrow is going to be spent fine-tuning everything that I've done. There is like, I've got to process the results and all that kind of stuff on the way out, fine-tune it so it's a bit less hacky, and do it properly with threads and all that kind of stuff, and see if we can get it running in a reasonable time frame. I.e. see how quick my laptop can run it. But no, I'm not going to sit for 20 minutes and test that theory. But that's my plan tomorrow, ladies and gentlemen. Otherwise though, today we've had dinner, which was chicken pie, homemade chicken mushroom pie. And we've watched some TV. I'm so happy with myself. I'm like, I'm not doing anything. So we had Graham out and we watched Bake Off. Bake Off, right, Laura said last week when we saw like the screenshots, we were like, oh, David Attenborough's on Bake Off. We're like, oh my god, we've got to watch that. David Attenborough's incredible. And then it's the bloody news journalist guy who from the BBC that always goes to like war zones and stuff. Well, like, that's bloody disappointing. But yeah, otherwise as well, I sent off all the documents I need to send for my car insurance, and that's about all. Tomorrow, long day on campus. I've got a 9:15 and a 5:15. Means lots of time programming on my laptop though. So we have that to look forward to, ladies and gentlemen. Otherwise, thanks for watching. I'll catch you later.